our project of Tyndall Effect. Our team members is Joaquín Martínez Cavazos, Bapiani Gama Álvarez, Carolina Salinas Escamilla, Carlos Garay de Bauer, Patricio Maldonado Chapa, and Fernando Chapón López. Why does the Tyndall effect occur? Well, the Tyndall effect scattering occurs when the dimensions of the particles that are causing the scattering are larger than the wavelength, the radiation that is scattered. It is caused by reflection of the incident radiation from the surface of or particles, reflection from the interior walls of the particles, and refraction and diffraction of the radiation as it passes throughout the particles. Some examples of Tyndall effects are in every day are the blue color sometimes seen in the smoke emitted by motorcycles and in particle two-stroke machines where the burnt engine oil provides these particles. And here we can see an image of the effect.
Where it happens? Okay, the Tyndall effect happens in colloids, and well, colloids are the mixtures where the substance is split into very minute particles and are dispersed through a second substance. And the size of the particles of the colloids can be ranged from 1 to 1000 nanometers.
A blue iris in an eye is blue due to Tyndall scattering in a translucent layer in the iris. Brown and black irises have the same layer except with more melanin in it. The melanin absorbs light. In the absence of melanin, the layer is translucent, and a noticeable portion of the light enters this translucent layer. That enters this translucent layer reemerges via a scattered path. That is, there is backscattering. The radiation of the light waves back to the open air. Scattering takes place to a greater extent at the shorter wavelengths. The longer wavelengths tend to pass straight to the translucent layer on other paths, and then encounter the next layer further back in the iris, which is a light absorber. Thus, the longer wavelengths are not reflecting back to the open air as much as the shorter wavelengths. Because the shorter wavelengths are the blue wavelengths, this gives a rise to blue hue in the light that comes out of the eye. The blue iris is not an example of structural color because it does not rely on interference to generate the color.
All right now, who discovered the Tyndall effect? The Tyndall effect was first described by a 19th century physicist named as John Tyndall. John Tyndall was a keen mountaineer and spent quite a lot of time in the Alps, both climbing and investigating phenomena such as glaciers. These interests in nature can also be seen in many of his other diverse discoveries, including his discovery in the 1860s, of which why the sky is blue in the day but red in the sunset. This will be explained in a later slide. Tyndall began to experiment with light, shining beams through various glasses and liquids and recording the results. He used this simple glass tube to simulate the sky, with a white light at one end to represent the sun. He discovered that when he gradually filled the tube with smoke, the beam of light appeared to be blue from the side but red from the far end. Tyndall realized that the color of the sky is a result of light from the sun scattering around particles in the upper atmosphere, in that in what is now known as the Tyndall effect.
Now, why is the sky blue? Well, that's a good question because when we talk about why the sky is blue, we have two colors, violet and blue. And violet and blue light have the shortest wavelengths, and red light has the longest. Therefore, blue light is scattered more than red light, and the sky appears blue during the day. That's why the sky is blue.
Now, the red sun sets. The lower the sun is in the sky, the more its light can penetrate the atmosphere to reach your location. More blue light is diffused, allowing the reds and yellows to hit your eyes directly.
And we're gonna follow this presentation with a video of our experiment.
Hello, my name is Opinion Alvarez from Team 5, and today I'm going to make an experiment about Tyndall effect. In here I have two solutions. A true solution of water and sugar, and a colloid of water and milk. Now, because water and milk, the solution of water and milk is a colloid, it's going to have the Tyndall effect present, while the true solution will not. As you can see here, you can clearly see the beam of light through the colloid, while you can in the true solution. This is due to a Tyndall effect that only occurs in colloids. Thank you.